Frank's here from Quest. Obviously, we've got a very good relationship with Group Technologies in Quest. One of the great Australian manufacturers. So they've got a facility in Tullamarine. You're based in Tullamarine.
Tullamarine, yeah.
And there's a fair bit of manufacturing that also goes on in the Dandenongs, from memory.
No, that's where I live. Tullamarine's where the manufacturing is.
Yeah.
And then we have our guinea pig studio, which where we have got the specimens for the experiments. That's in called Group Technologies in Pascoe Vale. You see.
And I recommend whenever the guys at Group put on a night, also I recommend if you come along to that, it's fantastic. So
and just don't book anything up the next day, that's all.
Yeah, exactly. Yeah, but they're involved in many of the biggest projects in Australia. So we had the Panasonic launch, and the audio was phenomenal there. And really, audio is about not even realising that there is an audio system, so it appears absolutely natural. So guys like Frank, are invaluable for those for the advice and audio systems. All right, I'll get them across.
Okay, thank you, Mike. Okay, what I've got here is audio design basics from commercial to full range background music. I'm not, when I say full range BGM and background, you know how it is when you get the customer that rings up and says, oh, I just want a background music system, and you walk in and say, well, here's your Nexo PA or whatever it is, and it's going to cost you $25,000, and they go, oh no, I just want a little one. So you go down, you rework your quote, and you put one in for $3,000, and you come back and they're saying, oh, it's distorting, it's kind of, there's a problem. And you walk in here there on a Monday morning, and there's absolutely barbecued the PA, and then you look and go, wow, what are we doing? Oh, well, man, like when the DJ came in, you go, what do you mean the DJ? Oh, yeah, well, we had 600 people here and a DJ. And you go, okay, yeah, there we go. So everybody's got a different idea of what a background music system really needs to be. So anyway, the real purpose of this is to help people and stay in business, make a living and stay in business in our industry. Now, this is the expectation panda here, hoping here to stay in business. And the question really is, how do you make a profit selling audio? Well, you probably can make a profit selling audio, because you sure aren't going to make a profit doing the video unless you get charge them for pulling the cables. There's not much money in the video. Security system, there could be a bit, but there is still a living to be made in audio. And the difference between audio installers is some of them know what they're doing and will install an audio system that meets the customer's requirements, and some of them don't. And really, it's probably the last remnant of the market where they will book you to do the job because of your intellectual property, because two people could install the same PA. One of them will install this and the other one will work fine. So, moving right along, the first question comes to the customer, or when you're evaluating a customer, is what is the scope of the system? What do they actually want? What they want, but what is really going to be required here? And of course, here we have the customer's budget on one end, and of course the customer's expectation on the other. So, reconciling the budget and the expectation. Now, what I'm going to do, I'll start briefly at the 100 volt line system, because the one thing a 100 volt line system normally has to do is reproduce voice. Ticket number 65, your Venus Schnitzel's ready, or whatever it is, or they've got to reproduce voice. And rule number one, no sound guy was ever fired because the voice was too clear. I don't know about you, but I go to Tullamarine Airport and it's paging passengers, unless I'm standing under a ceiling speaker, I can't understand a word that comes out of it. So that is conspicuously a voice paging system that spectacularly fails, but nobody seems to be able to do anything about it. Now, the funny thing is, with not 1 watt more power, they could have had a perfectly articulate and intelligible system. They would have needed to have spent a little bit more money, pulled a bit more cable, but they don't need any more watts. Because in most problems with a sound system, it's not that it's not loud enough. The problem is, oh, I can't understand the singer, or I can't understand what's being said. So what it comes back to is attention to detail and getting across to the customer what the customer really requires, or else they're wasting their money. So realistically, let's look at the scope of constant voltage systems. They're okay for announcements and low-level background music. They can give you really well distributed and articulate coverage. Some of them can be indoor-outdoor systems, depending on what they are, whether they're ceiling speakers or wall boxes. And they can be installed at a relatively low cost without specialist training, though that in itself can be a problem when you have people who've had no training at all try and put one in. Now, just very quickly, and bear with me if I'm laboriously going over something you already understand, but how they work. Here's the amplifier. At the output of the amplifier there is a transformer. The transformer takes the output of the amplifier and boosts the voltage and cuts the, you have voltage and current, and that can go like this, right? In a normal low impedance system, the voltage is down here and the current's up there. What we call a high impedance system, which is this, the transformer takes the same energy and reverses. Voltage equals pressure, current equals flow. So what it's doing at the output, it's boosting the voltage. The purpose of that being that a higher voltage will have a lower loss over a distance. So you can run wire long distances with lower losses. Whereas if you just had an amplifier, of course, with no transformer running into say 4 or 8 ohms, you're going to have a lot of loss over the distance. Now, at the other end, of course, we have another transformer that inverts the process. Now, you have our little tappings here, which determine how much wattage it's going to be drawing, and that inverts and it turns it back into a low impedance signal, which then goes into your loudspeaker. And of course, each one of these tappings will draw progressively more and more wattage up to the maximum of what it's capable of. Now, if you push more, where a lot of these fall down, and the difference between cheap ceiling speakers and expensive ceiling speakers may not actually be the speaker, it'll be this. Because the better quality transformer, the lower the losses that you have. And if some transformers, in fact most of them, will saturate. By saturate it means it becomes the amplifier equivalent of distorting. There's too much energy for what it can deal with. Another advantage with them is because you can have different tappings. Bearing in mind we've got them on a big parallel party line here. One needs to be louder, you use the higher wattage tapping. If it needs to be quieter, you use a lower wattage tapping. So in that respect, they're quite good, and you can hook a lot of them to an amplifier, and you can have a pretty consistent coverage. Now, where a lot of these things can fall over, let's say we've got a 100 watt amp and we've got 10 watt speakers. Well, we're going to have a problem, because even though theoretically 100 watts, 10 watt speakers is drawing 100 watts, with losses and with other things, and the transformers are never all that accurate. They often draw more current more than what they say, because they're trying to get the efficient, they want to make their speaker sound louder than someone else's. So they all exaggerate the spec. So consequently, for a 100 watt amplifier will not be enough. So what you'd do, you'd set these at a lower tapping. You'd set them, instead of a 10 watts, you'd set them at like 8 watts if there's such a setting. You won't really hear much difference, but it will take the load off the amp, or alternatively you use a bigger amplifier. So you always, when you're designing these things, and when someone comes in to buy a box of speakers and an amplifier, asking them a few questions is not a bad thing, because you can quite often, they probably need more than what they're going to buy when they come in, because consequently A lot of people that are doing 100-volt line installs not necessarily have a background audio and don't understand a couple of these basic premises. So it's always worth asking them a few questions. You always need more power than what the maximum rating of your speakers are. Now we move into the area of ceiling speakers. How many should we have? Now if you take a building like this is not that uncommon. You put in a bunch of ceiling speakers. Now if you were in a room, let's say you were in a function room or in a foyer or something like that, or let's heavens above Tullamarine Airport, and you're trying to run out a pattern of ceiling speakers. Now if you are going to put announcements through them that you want heard clearly, you can look at the quantity of ceiling speakers, you can sit there with a plan and you can go, well, there's X coverage. When we look at, this is a typical ceiling speaker, this is what they pretty much all do, contrary to what specs most of them publish. This is a very accurate measurement. Now you can see, if we look along here, these lines are the high frequencies, which is 5, 3, 2 and 1.2. The intelligibility, most of it's about here. There's a bit in at 2.56. By the time here we're into right into the very mid-range, and when you get down to 1K and lower you're in the wah sort of thing. Now you need this to hear a consonant in speech. We have vowel sounds and consonant sounds. The vowel sounds are the strong, A, E, I, O, U. The weak sounds are the H and the P and the F and all those, right? Now, they disappear into the reverberant field, and in a reverberant room, you'll have a lot of vowel sounds bouncing around the room, and that washes over the consonant sounds. In a lesser quality sound system, consonant sounds are harder to reproduce, and if there's a bit of speech or background noising or people standing around talking and there's a bit of echo coming from the concrete floor or whatever, you're going to lose a whole stack of them, and you're going to lose probably every 10th word, even sometimes you'll lose even more. And unless you're standing right under that ceiling speaker, if you're out here, you've lost all those, there's nothing there. So consonant sounds, forget it. So the intelligibility of the sound system when it comes to 100-volt line has a lot to do with having a whole lot of cheap ceiling speakers than a few good ones. That's for the same money, a pile of cheap ceiling speakers will work because the good ones don't have that much difference in coverage pattern. Okay, when you stand under it, they'll be nicer and more articulate and have a more high fidelity sound. But if you're outside the field, you're outside the field. So you're actually better off to buy a whole lot of cheap ones, which is not helping me because we sell expensive ones. But that is the point. If you've got a limited budget, more is better. More ceiling speakers at a lower tapping will give you much better concentration of intelligibility. Because as much as this ceiling speaker here, they might say, 140 dB cover, 140 degrees of coverage, you're lucky. You're dead set lucky if you're going to hear that out on the edge. So bear that in mind. Here's another picture. Now this one is a published spec. Absolute fantasy land. How someone could actually publish that, and it's a complete mystery to me because what's that green line? 10K. I'll be struggling to hear a 10K, but anyway, it's out there. It's a perfectly smooth pattern. I mean, dreaming, absolutely dreaming. But anyway, that's what gets published. So number one rule I found with specs is, don't believe them. That's realistically what's going to happen. You're standing underneath it, yep, you're going to hear it. You're out here, no, forget it. It's not going to make any intelligible sense to you at all. So, coming back to that point, no sound guide's ever fired because the voice is too clear. For clear voice, in most low ceiling environments, double the ceiling speakers. And it probably doesn't have to double up the power too. More is better. Okay, moving right along, back to the scope of the sound system. We've gone off the 100-volt line voice system. We've got music systems. Now, there are music systems that really have to do voice projection, but essentially we're moving I'm not moving out of distributed systems because there are such a thing as distributed systems that go up a serious notch too, but we'll get to that. We really have two primary forms of music system. There's the box hanging in the air, or the box on the wall, and then there's the sub-satellite system. Now, if you want to get full range sound out of one speaker box, the natural physics of the way bottom end is produced in a sound system, the box is going to have a certain quantity of size. The bigger the box, the more the bass. Unless you have some very funky trickery going on, and even then it's probably just fooling you into thinking there's bass, and that's where we get into processor systems and things like that, right? Now, I'll touch on that later. Here we have a system in a church projecting voice. This is actually one of ours. This is an asymmetrical projection system. It doesn't go like that. All that would do in most systems is hit the walls and ceiling. As you get up the room, you're getting twanged off the walls and ceiling, and you're having more reverberation. You're more out of the direct field, and the consonant sounds are being submerged into the vowel sounds again. So you're losing intelligibility. That's a 600 watts per box. It's loud enough, but in a lot of these boxes, as you get up the back of the room, you're going to be struggling. This is a bit better because that keeps sound away from the walls and ceilings. That will actually throw quite articulately for 50 metres, which is pretty good for a 10-inch box. And it's one of the very few array boxes that doesn't suffer from lobe, I think I call lobe interference when you put them next to each other, due to the way it works. But anyway, it's probably not a lot of your customers are into this, so we won't spend too much time on that. This sort of thing's a different story. This is where it's at if you want to have a nice full range music system that might reproduce voice okay. This is one of ours. This is a little sub-satellite amplifier, sub here, and a few options of little satellite boxes. Bearing in mind that a box that's producing voice, mid-range, essentially in HF, high frequency, does not have to be big. So you can stick them around the place and you can have a couple of subs. The sub tends to go everywhere. So if we look at the common, the benefits, if you look at a low, the benefits of a low impedance system, higher sound pressure level, in a high rood space. I think that should mean roof, but anyway. It's a full range system, and they can be installed as a point source, which means you have to go wiring up a whole building. You just shove a bunch of wires over there and hang the PA. The drawbacks are it's not uniform in its coverage. Get closer, it gets louder. Walk back, it's not as loud, and sounds can be having a bit of reverberation. As you walk around the room, you have waves coming off the walls that also interfere with it. So the coverage won't be as uniform. You are limited in your cable lengths due to losses, so you can't have an amplifier room in the next building. You've actually got to have it not too far from your loudspeakers. And most of these systems cannot be installed outdoors, most of them. So once again, there is the prospect of running a low impedance system as a distributed PA. These are a couple in Thailand, and unfortunately you can't see the rest of the PA, but they ran these low impedance because they needed more output. The problem was cable runs and box positioning, so they needed a lot of sound out of a small weatherproof box, as full range as possible, and to do this, they put the amps not too far from where the boxes were, but they had problems where they could run cabling. So consequently, they had to do it with a relatively small number of boxes. There's very few highly weather-resistant boxes that sound good. So that was what would normally have been done with a distributed system. They ended up doing low impedance. Here's another one. This is a place in Indonesia. This is the only part of the venue. As you can see, an architect's gone to town here. Where are you going to hang a box? How are you going to not just upset everybody as soon as you clang, here's your PA box. Where are you going to put it there? Well, once again, distributed system. Nice, even sound coverage, but high sonic quality in a distributed system environment. I'll get on a little bit more of that I'll talk about when I talk about these things. But anyway, that's a Quest system that went all through a venue. Now, these guys have one big room that they had a $150,000 Nexo system in, but most of the building, in other words, most of what people were hearing was actually these, which is a fraction of the price. Here's another distributed system. This one's in Thailand. This is going up a step. These are, you can't see the picture very well here, but that's another Quest installation, and they're using higher powered boxes in a place called the Bird Cage, where they wanted to be able to turn it up, and they didn't want lots of bass because they didn't want the bass carrying, because as you can see you can't really contain that bottom end, it'd go straight through that, but they wanted a strong projection, and of course especially in a lot of Asian venues they want clear voice, because if someone's singing they want to hear the words, and that was a distributed system that went right through quite a large venue there. Now, moving from the single box system to the next step up from a single box point source type system, we move into the sub-satellite. Now, that's where we can get away with, this is the old days, there's subs and top boxes. You don't have to have anything on that scale to have a sub-bass system. That's a venue in Canberra, it's got a whole stack of these around it. Once again, they had a noise problem. The great thing about this kind of system is nobody is very far from a box, so consequently it's loud enough. So you're sitting on that chair, well there's the sub, little 12-inch Quest box. We build the drivers for these in Dandenong, and this is designed to give you a lot of bass but not throw very far. These are 350 watt top boxes. They've got a terrific amount of output for a small box, but they don't throw and they're not harsh. So you can go into these kind of places where they're in a suburban area where there's, they've got the local resident action group ready to wind up at the drop of a hat or the slightest sound of a sub, and yet you walk into the place and it sounds like a Euro club. So consequently, and none of this is all that dear. This is not an expensive PA. Now, obviously the basics of that kind of system are, in a conventional multi-way system you'd have amps on these, but you've got high mids in a little box and your low frequencies are completely separate. Now, that's why with our amplifiers, every amplifier we make, including the new even 100 volt line ones, have got filters in them. So you can sit there and without having to spend more money on processing, because we work on the idea that the processing in a modern expensive PA, part of the cost is all the processing. So if we can get rid of that and just have a generic basic sort of common denominator that everyone pretty much uses, you don't have to buy an expensive processor to do a 2-box PA. Whereas if you're buying a Nexo or a D&B or any of those, there's a whole lot of expense you're going to that you're not getting the full benefit out of. So consequently, we put all this in the amps. It costs us $10 to build it into the amp. You go and buy a processor, it can be $1,200. So consequently, that's kind of our approach, is to keep it simple and keep it functional system. Now, here's a little venue in Canberra. This is a bar. It's actually a multi-level bar. Can't see it too well on this picture, but there's a pair of Quest boxes hanging up here. And over there and in the wall is a sub built into the DJ booth. Now, there's a guy in Canberra who does lots of these kind of installs and does very well out of it too, I might add. He does all of the small to intermediate venues. He puts these in because he's kind of a one-man show, and to go and fix things is a pain in the ass. So he basically puts these in because he knows they won't break and they're really easy to use. So that's a sub-satellite multi-way system. Once again, didn't cost him a lot, but he made good money selling it. Now, here's another venue. Here's another way to do it. This is in Flinders Lane. This is a place called the Saki Bar and Restaurant, owned by an Asian conglomerate that do very high-end, high-quality bar restaurants. Now, you could think, well, why didn't you just put in some ceiling speakers and want a background music? But they said, no, we want a sound experience. We want people to walk in the front door and want to stay here. And they're probably charging $20 for a spring roll, so consequently the longer you can stay there and the more sake and spring rolls the better. So they wanted an immersive sound experience, but they did not want to see a PA. So what you have up behind the lighting are the subs. The subs are this. This bolts to the ceiling. You can mount this in a dozen different ways. And they have a pile of these. Okay, it's a black box against a black roof, so you don't really see that. Now, when they were looking for a sound system, a lot of different companies went in and pitched high quality, expensive PAs. In the end, they looked at it. Each one of them, as much as they were very good, had something that made them difficult to use in that environment. And in the end, they ended up buying a pile of these and the subs and a stack of these amplifiers, and then ran the whole lot from a controller. And the actual sonic performance out of it is amazing, because they're not pushing it that hard, but you walk in, a big, comfortable, full range sound, and then later in the night they could put a DJ on. And okay, it's not loud DJ music, but it's up there, it's starting to get up there. And once again, they put enough in, system would be lucky if it got to 60% power. So really what we're moving into is a new market. And the new market I'm calling architectural audio, is basically sound designers and venue owners. When you think how much money they're spending to do that, it's an absolutely gorgeous piece of building work. They've restored an old venue, an old building, and then decked it out. They've spent some serious money. Now, when is the last time you saw a speaker box on an architectural render? You know, an architect comes along with a client, here's his artist projection. Have you ever in your entire life seen a sound system drawn in? Doesn't happen, right? You get the phone call, you know, oh, we're renovating this building. We're doing, you know, this, that and the other thing, and we're going to do this, and what's the scope of it, and blah, blah, blah. So you go and you see the customer and they want a quote and how much it's going to cost. So you ring the architect. The architect doesn't ring you back. So you send him an email, doesn't answer your email. Finally, you sell the customer something, you turn up to put it in, and the guy is horrified that you're going to install this into this sculptured venue, yet he wouldn't answer your phone calls. So consequently, we have a disconnect. We have the sound system, and let's face it, the sound is a very critical part of the venue, and you've got the guy who's designing the venue who designs with his eyes, not his ears. So, apart from the fact he's probably made something that's sonically horrible, you can't install the PA that you want to install because it doesn't look right, like that's going to save the day, and you can't put it where it needs to work properly because something else is in the way, or there's nothing structural there, or whatever, you know. So we looked at that and we thought, this is an emerging cultural scene, and you can't go wrong designing for a culture. So basically what we came up with was the concept of architectural audio, where you could make small, compact, Lego-style building blocks that could integrate into any kind of design space and kind of look good and kind of work, and not be so critical in the way they have to be installed that a failure to meet its requirements would destroy the performance of the system, which is pretty much everything that I intensive PAs. Even the ones that make, like Nexo and DNB and Maya Sound, they've all got critical things you have to do to get them to work, because they're engineered by engineers who are trying to design the perfect sound system. They're not trying to put the perfect sound system into the dud gig, which is of course what we are trying to do and what you are trying to do. You've got the completely not perfect venue, the completely no budget, you know, we're back to the, you know, the little ceiling speaker and the guy's expectations are for a concert system. And somehow you've got to reconcile that. So that's why we went into this kind of architectural audio concept. So basically what we've got here is a sub you can hide, a top box you can hide, and then it came down to the electronics, because ultimately we wanted to make Lego blocks, but we didn't want them to be toys. So we came up with simple and uncomplicated solutions that will pretty much work anywhere. So we make this kind of thing, which is, this was a very involved process to develop these, the type of loudspeaker that's in it to make it work. To get the bass response out of this, we had to completely redesign how loudspeakers are made, and to keep the IP rating, bearing in mind that this will take full immersion in water and still work. Now, most IP rated systems don't sound very good. You know, they'll work, but they're not hi-fi. And the other problem with little box systems is they don't project voice. And remember, no sound guy was fired because the voice was too clear. So we had to make something that had good bass response, that was totally sealed, that would give you good voice and high power handling and be very low in price, but be able to be shrunk. Now, we've got an 8-inch speaker in a box that would normally be 6.5 to 7-inch size box. The actual loudspeaker itself is the cone area. It literally goes from one side of the box to the other. We've completely redesigned the way the loudspeakers are made so we could fit it all into this, and then we put in a resonance circuit to simulate the action of a port, but this actually goes much lower than a ported box will go. So, and then the other thing we did was design a installation system so it would be very quick and easy to install. So this could be a single box, it could be used in multiples, it could be a distributed system, it could be high impedance as a 100 volt line system, or low impedance, but being 16 ohms, you can hang 4 of these off one channel of an amp. Now when you take something like this, which is a little more of a more expensive amp, it's not really expensive, but these are made here, it's a very high-tech amp. The idea that you could hang out 8 of those boxes off one of these suddenly brings your whole system price down. And when I do the demo in a minute, I'm going to show you the difference between the performance at 100 volts compared to at the low impedance setting. You can see that running a low impedance system with a couple of good quality amplifiers, for not spending a lot of money, you can get terrific performance for something that's still fitting into a budget. So anyway, what I'm going to do is I'm going to run a bit of music. I'll start with just running these at full range, and then what I'm going to do is talk about integrating the sub. You can just bear with me for a sec, I'll find a track. So it's okay, we'll start just with running the top boxes. Now, I can only get a certain amount of level out of this because I'm going from an iPod into an amp, so, you know, I don't really need a preamp, but I'll give you an idea.
Trail of broken hearts, looking back at you. Now and from the start, these words. So,
now, if you imagine, let's say you've got a public area that you want to be able to put a bit of level into. You want something a bit better than a ceiling speaker background music system. If you had 8 of these and one amplifier, you could actually pretty much cover an area the size of this, a fair bit of this ground floor, with a sound system that would get over the top of people talking if you wanted to make an announcement, and that would sound pretty hi-fi. So
is that running off 100 volts or 100?
no, that's running at 16 ohms at the moment. That's just a pair of boxes. Now, bearing in mind, this is not crazy about the 16 ohm load. If you run this into lower impedances, you get a lot more out of it. I'm not getting this to full biscuit because I can't get any more juice out of the iPad. But that gives you an idea, just for a couple of boxes in an area here. Now, if I was to do the same thing, I'll turn it down a bit and run the sub. The hard part, subs are always hard because they're big. And as I said earlier, you need, the whole physics of it are such that you cannot develop low frequencies from a box that size. Now, as I said, there's some trickery you can do with processing, etc., etc. There's some other trickery you can do with the actual design. We do make some small subs, but still people say, oh, but it's a bit hard to hide and it's a bit this. So then we developed this one. This is a bit unique. It looks like a single chamber box, same sort of thing as this sort of thing. It's actually not. It actually has an outward facing speaker. And the way this one works is you have to push it against a wall, a ceiling or a roof. And it actually uses the chamber under the box as part of its active chamber area. I'll turn around and show you how it works in a minute. It's relatively easy to hide, but it goes down extremely low. Now what I'll do, I'll run that track again. I'll turn the top box down a bit. Once again, I'm a bit limited with what I can get out of it, but you'll see what I mean. Even in a space like this, if you just ran ceiling speakers, say a good quality ceiling speaker, and you were just one of these in each room, you would change the whole sense of warmth and atmospheric in the room.
Trail of broken hearts, looking back at you. Now and from the start, these words will travel through the Godspeed of trust. Will settle the dust we've been passing through.
So you can see it just adds a little extra dimension to it. Now, if I was to say put on, just for a few seconds of say a techno track for instance. Now, very well, we're talking about a little plastic box PA here, and that's running at about 20% at the moment, if you're lucky. So, without going to a lot of expense, and just by positioning things in the right place around a room, you can actually get that's a pretty good background system, essentially. And in some sort of venue environments, you'd almost, if you run 8 boxes in a not particularly big room, 6 boxes even, you would get a pretty decent performance from what is effectively a very cheap PA. Now, as far as the amplifier solutions go, that was listening to this little Q1K. What we have here with this is this tool you get with it, and this little screwdriver thing can plug into this so you don't lose it. This comes off, and behind here, this panel, you have a whole lot of little switches. I kind of wish they'd have given us, we're probably going to give people a magnifying glass so you can see them, but the point is that with that, you can configure this amplifier in different configurations. It can be a sub amp, it can be a top end amp, it can be both, as in one channel sub, one channel top end. It can be a 100-volt line amp, it can be a mono sub. There's lots of, you can even switch it so you can switch off these knobs so that you can set it up and then throw the switch and go away. And you can run them in a rack of 4 of them, and you can have 4 channels of 500 watts, or you can have, 8 channels of 500, 4 channels of 1000. There's quite a lot you can do with it. So that was really a bit of an architectural audio solution, and when you think that you can run 8 boxes off this, if you were running this around the room in a low impedance configuration, you're going to get a lot of horsepower out of that. That's 1,000 watts you're going to get out of this little 8-box system. And it isn't actually a very expensive PA. Now we move into this kind of thing. This is a new one. These are just going into production now. We've just started making these. So, 100-volt line amps that have the capacity to, to run 100-volt line or whatever low impedance in the old style of amps. In the digital sort of solid state amp world, I don't know of any that will actually work as both 100-volt line and low impedance. Just due to the nature of the way they work, you can't get an output device that can work through that range. So that's why they had the transformers in them, you see. Now, because the transformer can it can produce different impedances, but the amplifier it can't. Now, what we've done is we've developed, using the output modules for these are made in Denmark for us, and then we build the rest of it in Australia. We've taken that same concept in this, we run very high voltage rails, and what this allows us to do is run any impedance out of this amplifier. So okay, this one's a 4-channel one. There's 4 channels of 280 watts, which is 250 into 100 volts, or 280 into a lower impedance. Now, because we're running such high voltage rails, its performance as a low impedance amp is amazing. The actual stick that comes out of this thing compared to its technical wattage rating is enormous, because it can sustain very high powered transients for brief periods of time. It allows us to push the whole average level up. So as much as it's effectively a 250 watt amp, it can sustain peaks of something like 700 watts. So it's quite extraordinary what this thing can actually do. And it's the only amp that I know that I could sit here, which I'm going to do now and do a demo, and just switch it through all the tappings and not even stress the amp at all. If we go back to our little girly track again, I'll show you what I mean. Now that's at 16 ohms.
Trail of broken hearts, looking back at you.
And that's when you go into the transformer mode. You can see there's an enormous loss. That's at 60 watts of transformer. And then they just get quieter. And then we're back to 16 ohms. So the point I'm making here is a low impedance system can just give you so much more than a 100-volt line system can. And when I look at this is pretty much wasted when you go into 100 volts. And it's the same with all of them. I mean, this one's a ceiling speaker version. We build a ceiling speaker version of the same product. This one's a 6-inch. And I'll pull out a 6-inch one in a minute, which I have and this is that you can have a mix and match, and they're all going to sound the same. In most manufacturers, if you buy their ceiling speaker version, it's going to sound completely different from the wall box. We figure that once again in an architectural audio solution, you may have to use a mixture of wall boxes and ceiling speakers, and you want them all to be the same. This has an extra little feature, which is a top-end boost, which we have an EQ circuit in there, which we call the atrium setting. So if it's up high in the sky, in an atrium, rather than sound like it's up sky, you actually want a vocal image to be pushed. You want it down where the people are. So we've got a little boost setting here, which you can you can wind up and it changes its sonic profile. But outside of that, it'd be the same as a 6-inch box. So, you know, if we look at that. Okay, it's not so flash in the bottom end, but if you had a pile of these and you stuck a sub somewhere, you would have a pretty high fidelity sound system. Now, speaking of 6-inch boxes, you know, what's that they say? Here's one I prepared earlier. Okay. Now, this is the wall box version of this one. Now, as I said, we do make them weatherproof, and by weatherproof I really do mean seriously weatherproof. As far as I've been able to find, and in our testing, this is the most high fidelity weatherproof box you can buy on planet Earth. Now, it loses a little bit of top end when it's been in a bucket of water, but once it blows all the water off the top end diaphragm, it comes back again. So you do get it. You do get it back. Let's try that again.
Trail of broken hearts, looking back at you. Now and from the start.
So that when it dries off a bit, the cone dynamics improve. But anyway, that's you can actually get great voice projection and high fidelity response. The other thing we did when we developed this is a patented system that we have, which is this bracket. Now, one of the things that limits you in box design, when you've got to put a bracket on it, and you're trying to make something discrete, and you put this clunky piece of steel on it, and then it'll only point that way or it'll point that way and you can't tilt it. And then you get the other type of bracket with your ball type bracket where, you know, you get there and you get a spanner and you do it up and you go, damn, I need to lift it a bit, and you undo the thing and then you move it, and now you've already indented the ball, and now you try to do it up and it goes, you go, damn, I want it there. Then you have to unbolt it, turn it around that way and start again. And if you're lucky, you'll get it remotely close, so then you come back 3 months later and it's got a dose of the droops, you know. So what we've developed is this system. You don't need anything to put this up. You don't need a spanner, you don't need anything. You put this thing on the wall, just do it up, finger tight, can't fall off. If you want to put it around the other way, let's say you want an angle that way, you just work out which way you want it, just do it up. I could hang off that, wouldn't break. This can carry 100 kilos, so it's really, really strong. It looks like plastic, it's not plastic, it's actually an aerospace composite we buy from Switzerland that they use in the A380s and all that. So that was for us our little finishing touch, where we can make it super easy to install, look nice, have the maximum amount of flexibility. There's also a ceiling version of this where this just got a bend in it and you can bolt it onto a ceiling, and same thing. So anyway, I'll end it at that point. Without spending a vast fortune, you can get pretty high fidelity PAs. As I said, we're just in Tullamarine, so anyone thinks of a question some other time, they're welcome to ask. We try and come up with useful solutions. That's why we give you this little scratchy marker when you draw it, when you put your speakers up. Things like that. I mean, it's simple, easy to put together. So we try and come up with functional, practical solutions, and then build them really tough. Basically, over engineer everything. And then the specs we quote are also very conservative. Something, you know, we've got a new amp we're about to bring out. We measure them at 4,000 watts a channel. We're calling them 2.5. So we've gone the opposite way. The rest of the world seems to have gone into fantasy, you know, the 1,000-watt plastic box or something. Well, we've gone the other way. We've gone to over-deliver, under-promise, and basically we make them so they won't break. Anyway, I'll leave it at that. Thanks for your... Unless you've got a question? Well, we make a couple of versions of this. This one is... I have to have a look. They all look the same to me. But anyway, this one is the MXC. This is the MXC, which is basically a ceiling version of that. We also make one called a QTA 2080i, which is the same casing. We just haven't put cheaper bits in it. We've actually just designed bits that are cheaper to make and redesigned the electronics in it. But that's also got the atrium boost, and it's about 30% cheaper than this is. The difference is this will handle more power. Spec-wise, it's a little better. They've had some consultants in Sydney. I was rung up and told about it last night. We did a shootout between all the ceiling speakers, and this smoked an $800 ceiling speaker by a competitor brand. So we're pretty happy with this. I can't begin to tell you the pain and pathos that went into developing these. We've been at it for years, basically, and everything in it has had to be made for it. We had to develop a whole lot of things that did not exist to do this. Even down to the way this is moulded. You'll notice there's a border around it. That's there as part of the aesthetic of the box. I've had plastic moulding guys look at this and say, how do you get that out of the mould? I go, we have secret method. You see, so what we've done is we've developed a moulding technology that actually allows us to mould something that shapes that complicated. So anyway, guy who did, look, there's a guy called Martin Steck. He's on the Quest video. If you have a look on the Canadian guy used to be one of the owners of Paradigm. He was the head engineer. He did the design. He now lives on a luxury yacht in Hong Kong Harbour, and he's got a test facility in Shenzhen, and he basically collaborated the guy called Michael Chijoff did the industrial design, and Martin did the driver design. So Martin designed the drivers, and he designed the driver in that as well. So he's very wealthy, but his hobby is doing stuff for us, because he likes. Everyone else wants to build a 6, an 8, a 12, a 15 because they've got a market, and someone else has got the market, and they're all trying to compete with each other building the same things. He likes working with us because we're trying to do something different. So, and we don't care what everyone else is doing. We start at the problem and work back to a solution, whereas everyone else is, from what I can see, is pretty much building just copies of each other's product. The only people who don't do that to a certain degree that I can see are the French, and particularly Nexo are a extremely out there engineering based company. They've developed some fantastic technology. And there's a whole lot of there's a few small companies in Europe and in the US that build very, very clever product, but boy do they charge for it. And what we're trying to do is build clever product that can help you stay in business. Because realistically, this is the sort of thing customers buy. They don't go and buy $1 million PAs every day.